Hello, my name is Luis Chavez, and I am the CTO of Replit. Replit is the agentic creation platform. We believe that everyone should be able to put their ideas to work without the need to have deep technical expertise to do so. We help our customers build and publish web and mobile applications, create and iterate on beautiful designs, and launch businesses from a single place. In this talk, I'm going to tell you how Replit has transformed internally this year through the lens of automated software verification, which I'm sure most of you can resonate with. This talk is going to consist of two parts of the journey to become a self-driving company, starting with engineering and then expanding to the rest of the company. Let's talk about engineering first. In the last 7 months, we drastically changed how engineering is run at Replit, thanks to, in part, AI and coding agents. Engineers at Replit have nearly tripled the code output so far. Intuition said that tripling output should have completely broken down code reviews, quality, or stability, but so far none of that has happened. Thanks to other interventions, mean time between failures has stayed mostly flat, and mean time to mitigation has actually decreased. We thought that there was something special about giving engineers extra capabilities and removing the slow parts of their workflows, toil essentially, so that they could focus on delivering value and improving the product instead. What ended up happening is that we transformed into a self-driving company. A self-driving company is not one without people. People still choose the destination. Human beings are now more in charge than ever of what matters, what trade-offs to make, they exercise taste, and they take responsibility for the outcomes. Thanks to coding agents, humans no longer need to do most of the legwork within the realm of coding. But coding is not the only thing that engineers do, far from it. They spend most of their time doing other activities than coding. But we could still apply the same patterns to other parts of their job. Humans still set goals, but the agents are the ones that gather context, do most of the work, and iterate until the work is done. Most importantly for this crowd is the fact that one of the most important parts of the setup is actually checking the results. This is, in essence, doing verification at every single human-machine interaction. Finally, if the agent can't solve a problem on its own, it should escalate to human whenever judgment is needed, so that humans are still around the loop. You probably heard of agentic loops before, and they are in essence what the whole system is engineering around. It starts with a human asking the agent to solve a problem, either posing a question or in general setting a destination. Afterwards, the agent takes that goal and uses a combination of company-wide and also local semantic layers to explore what is needed to reach the goal, and then make incremental progress towards it. Importantly, this semantic layer and the agent context carry information that help the agent come up with a good strategy to verify whether the goal has been reached, and then iterates until the verification passes. The output is then the result of this verifiable task. So I'm going to go through examples of loops that we have done at Replit at every stage of the software development lifecycle that highlights where verification comes into play. Originally, I mentioned that engineering throughput tripled, but code review latency stayed roughly flat. This was because we also turbocharged the review process with the same loop idea, not just the coding part. We evaluated multiple vendors, but we ended up integrating the code review process with some of our other tools and semantic layers internally. This means that the agent that codes and the agent that reviews both get the same rules and guidelines to align themselves and expectations. One important change in this process is that the agent is encouraged to find counterexamples every time it assesses correctness failures, which saves human review time and lends itself to have more trust in the process because they can see the counterexamples. We took the idea of automating reviews a little bit further than just automating the code review itself. We gave the agent the ability to assess the risk of every single PR, and the agent can approve them if the risk of that PR is small and the author is already part of the group responsible for the maintenance of that part of the code base, since they were already responsible for the outcome. Of course, there are still some parts of the code base where we always require a second human reviewer. Security, authorization, and billing are good examples of this, where the stakes are significantly higher. Even with this more speedy review process, we haven't seen an increase in reverts or incidents. The important part is that the code review didn't become a bottleneck for the process, because the review itself became a loop. Loops have also helped perform maintenance tasks that would have been taxing on the team. Toil. Loops are great for broad changes. As an example, we completed a long-stalled CSS system migration that had been attempted a few times in the past, but failed due to the sheer amount of work needed to complete it. Traditionally, this would have required either a very large team of engineers or a top-down mandate to fund, or an advanced tooling system to perform this large-scale migration. Instead, this was done by a single engineer, producing 309 PRs over the course of 2 months, touching almost every single file in the codebase. The agent was able to perform snapshot tests of every single PR to make sure that the change didn't cause any significant regressions. Loops also help dive into very deep problems. A very hard networking bug that had stumped several engineers since last year was solved by a loop. It proposed multiple hypotheses of what could have gone wrong, systematically went through every single one of those hypotheses, adding observability where it was required, and then ruling each one of them out until it found and fixed the root cause. All of this was thanks to the ability for the agent to perform validation on its own. And finally, loops don't necessarily need to be one-shot things. We have been continuously burning down on flaky unit and integration test maintenance by having a loop run every afternoon once we get the flake report, with PRs that are validated before an engineer needs to attend to them, essentially automating this whole process. Another great adoption of automation was in the realms of security and reliability. For security, specifically for penetration testing, we built a very realistic capture the flag harness and gave the agent full control over a very, very tightly locked down sandbox with no rules other than the goal to access information that the agent shouldn't have access to. Giving the agent this ability to verify that it has actually succeeded in breaking a system has found dozens of vulnerabilities, and we've been able to fix them before external attackers have attempted them. Every time there's an incident, we get an agent automatically dispatched to look at everything that has changed recently and gives engineers suggestions of how to mitigate this incident. Thanks to having the access to the codebase and also a large corpus of company-wide knowledge, this system that we built ended up matching other vendors' quality, but at 1/10 of the price. And finally, the piece that brings everything else together, continual self-improvement. We put a loop around improving the Replit agent itself. Every day, there's a loop that goes through all of that day's agent's execution traces that have either encountered an error, a slowdown, or a suboptimal human interaction, essentially the human complaining about something. It then clusters all these traces by facets, where there exists commonalities between the traces, and performs a deep analysis on a few representative traces. This makes the problem tractable, because analyzing every single production trace would be completely infeasible and very expensive. The second, harder half of the loop is to find all the inefficiencies in those traces and propose improvements to either the prompts or the tools. Once an improvement is found, it is validated using our published benchmark, BibBench. If there are no regressions, a PR with an associated A/B test is proposed to run the next day. If we see the desired effect in production, we can canonicalize that change. Otherwise, it is discarded and then a new run happens. In this way, we have been able to find improvements in a scalable fashion that would have been impossible otherwise. So, after the success of this experiment for engineering, we did something bold, guided by our mission of empowering the next billion software creators. Why should only the engineers have these superpowers? What could happen if we opened this up for everybody at the company, no matter what their role was? The picture for improving software engineering should be significantly easier to imagine. There are way more treaded paths, and there's also existing literature on how to improve this. Teams have traditionally relied on unit and integration tests to ensure that the product behaves in the way they want. But what about all the other non-engineering use cases? How do we manage to achieve a similar transformation for the rest of the company? I mentioned before that we use a semantic layer, which is a human-curated, ground truth knowledge base for the rest of the company. We have a team that writes rules and governance for these shared definitions, categorizes the canonical sources of truth, and maintains vetted paths for getting data. But this knowledge base is not static. It's always evolving. And we can't really trust the system if the agent starts giving wrong answers. That would cause our own internal users to stop using the system. So how do we ensure that its quality is up to par? The first answer is in-loop validations. Part of the semantic layer encodes how the agent should validate its own assertions. This comes in the form of tools to get access to other related datasets, and guidelines to get the vetting, grounding evidence, and reporting this evidence together with the file results. Every item in the semantic layer has this guidance. As an example, if the agent sees a drop in a key metric, it should always correlate that drop with other events so that it doesn't jump to the wrong conclusion. Maybe the drop is a data issue, and it should report it as such. Maybe there was an incident. Maybe we changed part of the product that made another metric go up instead. All of this information is crucial to give to a human to contextualize the results. And similar to the use cases for software engineering and automatic agent quality, humans cannot be part of each individual loop. That would be antithetical with a self-driving company. But humans still need to be involved around the loop in the process somehow. We have found a very good middle ground by having agents perform a daily sweep of the system's outputs, very similar to what we did with the agent self-improvement loop. This sweep proposes several corrections found from discrepancies between data sources and human feedback, as well as escalations to humans for help. Humans now only need to validate the corrections in the form of pull requests against the semantics layer repository. Every merge correction compounds trusts. Our employees know that the errors are quickly corrected and the system gets better over time. The team that owns the semantic layer has to dedicate less time every day to answering individual questions, and everybody at the company gets better answers quicker. In a more traditional model, one human knowing about a correction means that just that one human knows how to avoid a similar issue the next time. With a company-wide semantic layer, every employee now gets the benefit of this new knowledge almost immediately. We no longer have the problem of different individuals having a different way to answer the same question. So the team that maintains the semantic layer can dedicate more time to add more validations to the corpus and to be able to better stand by the answers that the system generates. You probably heard the term token maxing in the past. This is optimizing for AI token usage and treating the volume as proof of productivity. We're decidedly not doing that internally. Instead, what we're going for is outcome maxing. Maximize the results, not the steps to get to the results. Outcomes are obviously better aligned for us because they are what drives value, not the spending that is needed to get to the value. This also happens to get better aligned with how most effective people think. They think about getting to the result, not necessarily outlining the tasks to get to the result. And part of the alignment of outcome maxing is that we also want to minimize time to outcome, which is correlated with less spend. But one crucial prerequisite for outcome maxing mentality is validation, both in loop and around the loop. The system can't determine that it has reached an outcome if it doesn't have a way to measure it. Then, measurements that are used often enough become company-wide guardrails, and also methods to prevent regressions. A few closing takeaways. Testing used to be a phase in the software development lifecycle, but now it has become a property of every single loop at a company. The more effective individuals are the ones that can help the system come up with validation strategies that can bridge faster and also can be reused. This is not limited to just software engineering nowadays. Toil has never been easier to chip away. It is not fully automated yet, but when the loops to remove toil are designed by people who think in quality, they end up producing significantly better results. The verification mindset has never been more valuable, and it is now crucial at every single part of a self-driving company. That's it for me this time. Replit has learned so much from this journey, and we're so happy to share it with you all, and I hope you can put it to practice. We're also planning to release this as a product very soon. Thank you for your attention, TestMu.